Welcome to another deep dive, everybody. This time, we're going to get into a pretty cool element, ruthenium.
Cool is an understatement, I think.
Uh-huh. Okay,
I might be a little biased, of course, but...
No, I get it. It's fascinating stuff.
Yeah, it is.
So ruthenium, it's named after Russia, right?
Yeah, you got it. Comes from Ruthenia, the Latin word for Russia.
Okay, cool. So right away, we've got this connection to Russia, and we'll get into the history for sure later.
Definitely.
But one of the things that jumps out at me from the research we did is that ruthenium, well, it kind of breaks the mold when it comes to the periodic table.
It really does, yeah. I mean, it's in group 8, but it only has one electron in its outermost shell.
And that's weird, right? Because, like, usually elements in the same group kind of act alike.
Right. Because of those outer electrons, they're the ones that determine how an element bonds with other elements and basically how it behaves chemically.
So this lone electron, does that make ruthenium some kind of rebel?
You could say that. It definitely gives it a unique personality.
Mm-hmm.
And this quirk is what influences a lot of its behavior, like how it reacts or, doesn't react with other elements.
Okay, that's super interesting. But before we get into all the chemistry, can we just back up a second?
Sure.
What does ruthenium even look like?
Well, picture a really shiny, silvery white metal. It's almost like a mirror, super hard, and it doesn't tarnish easily, like at all at room temperature.
Oh, okay, so it's a tough cookie.
You could say that. It's known for its resistance to wear and tear.
Very cool. Anything else?
Well, it has an incredibly high melting point, over 2,300 degrees Celsius.
Whoa, okay, that's hot.
Yeah, something like 4,200 degrees Fahrenheit. So it can withstand some serious heat.
Wow. Okay, so we've got this super shiny metal, dense, hard to melt, and our sources mention that it can withstand even the strongest acids.
Well, yeah, that's right. Like aqua regia, which is so powerful it can dissolve gold.
Okay, so nothing can touch this stuff.
Well, not quite. It is pretty unreactive. I mean, most chemicals just don't affect it at room temperature.
So there must be a catch, right? What's the weakness?
Well, yeah, there's always a weakness.
Spill it.
It can be attacked by oxidizing agents like sodium hypochlorite.
And that's in
Bleach, yeah.
bleach. Okay, interesting. So even this super tough metal can be taken down by something you can find under the kitchen sink.
Pretty much, yeah, especially at high temperatures. And halogens can also react with it under the right conditions.
Wow. Okay, so it's like super tough, but with very specific vulnerabilities.
Exactly. And, that brings us back to that single electron in its outer shell.
Oh, right. So it's not just a random fact. It's like the key to understanding his behavior, this strange mix of strength and weakness.
Yeah, and that's what makes ruthenium so interesting to study. But before we dive into all that, maybe we should talk about how rare this stuff actually is.
Yeah, good point, because I was reading that it's one of the rarest metals on Earth, right?
Absolutely. We're talking about 100 parts per trillion in the Earth's crust.
So how do we even get it?
Most of it is obtained as a byproduct of nickel and copper refining.
Oh, okay.
Yeah, it's often found alongside other platinum group metals. They sort of hang out together.
Hidden treasure. And speaking of treasure, one of our sources talked about this ancient nuclear reactor where they found ruthenium.
Oh, yeah, the Oklo natural nuclear reactor. It's in Gabon.
Okay, I remember reading about this. So basically, nature was splitting atoms way before humans figured it out, right?
Billions of years ago.
It's wild.
And they found a unique ruthenium deposit at this site.
So it's like a time capsule from this ancient nuclear event.
It really is. Gives us a glimpse into what happened way back then.
That's amazing.
Yeah.
Okay, so we've got this element that's tougher than nails, rarer than a winning lottery ticket, and has a connection to natural nuclear reactions. I'm hooked. What are people actually doing with this stuff?
Well, its uses are as surprising as its properties.
Okay, I'm ready for it.
For one thing, the electronics industry relies heavily on ruthenium.
Electronics, really? So, like, our phones and computers?
Yep. It's super durable and resistant to wear, so it makes a great material for electrical contacts, keeps those connections strong and reliable.
Wow, okay, I had no idea. So what else? Any other surprising uses?
Oh, absolutely. Ruthenium is also kind of a connoisseur of catalysts.
A connoisseur, huh? I like that.
It's involved in some very specific, high-end chemical reactions that are essential for making all sorts of everyday products.
Like what? Give me an example.
Well, there's something called Grubbs catalyst, which is used in a reaction called alkene metathesis. It's a big deal. Won a Nobel Prize even.
Alkene metathesis. Sounds complicated.
It is, but basically it lets scientists rearrange and connect molecules in totally new ways.
So it's like a molecular building set.
Exactly. Ruthenium helps create new materials and compounds that we use all the time, from plastics to medicines.
Oh, okay, this is blowing my mind.
Yeah,
But I have a feeling that's just the tip of the iceberg.
you're right. There's so much more to discover about ruthenium's applications.
I can't wait. But before we dive into that, maybe we should take a step back in time and learn how this elusive element was first discovered.
Yeah, good idea. Because the story of ruthenium's discovery is full of twists and turns.
Oh, this is going to be good. Lay it on me.
Well, it starts with a bit of a mystery, actually.
A mystery, huh?
Yeah, some evidence suggests that a Polish chemist named Jadze Śniadecki might have isolated ruthenium as early as 1807. He even gave it a name, vestium.
Vestium, the lost element. What happened? Why isn't it in the periodic table?
Well, he wasn't able to really confirm his findings, and other scientists couldn't replicate his results, so eventually he withdrew his claim.
Oh, bummer. So back to square one.
Not quite. In 1825, another scientist named Gottfried Osan thought he'd found 3 new elements in platinum ore from the Ural Mountains. One of them he named ruthenium.
Wow, 3 for 1. So he was the first to use the name ruthenium.
He was, and he chose it to honor his homeland, Russia.
Cool. Naming an element after your country, that's got to be a point of pride.
It was a big deal, actually. Kind of set a trend for other elements being named after places.
But if he named it, why doesn't he get the credit for discovering it?
Well, he ran into problems too. He couldn't consistently isolate ruthenium, so the scientific community wasn't convinced.
So the mystery continued.
It did for a while. But then, in 1844, a Russian scientist named Karl Karlovich Klaus finally cracked the code.
He's our hero.
He was analyzing those same platinum ore residues from the Ural Mountains, the ones that Osan had been studying, and he was able to definitively isolate and identify ruthenium.
So, like, persistence paid off.
Yeah.
It's amazing to think that this one element had so many near discoveries before it was finally brought into the light, so to speak.
And it all started with those platinum ore residues. Who knew they held the key to unlocking this remarkable element?
Okay, so we've covered a lot of ground already. Ruthenium's weird electron configuration, its mysterious discovery, and those hints about its uses.
Just wait, there's so much more to come. Welcome back to our ruthenium deep dive.
All right, so before we took that little trip back in time, we were just starting to scratch the surface of what ruthenium is actually used for.
Oh yeah, we've only just begun.
We talked about how it's used in electronics, right?
Yep. And its durability is what makes it so valuable for electrical contacts.
Keeps our gadgets running.
Keeps them running reliably. And actually, there's a lot of research going on right now looking at how ruthenium could be used in the next generation of electronics, like in microchips.
Oh, really?
Yeah.
So it's not just about maintaining our current devices, but also paving the way for future tech.
That's it. As our devices get smaller and more powerful, we need materials that can keep up,
Makes sense.
Ruthenium can be manipulated at such a tiny scale, and it's got that amazing electrical conductivity.
Plus the durability, right?
Exactly. So it's a strong contender for all sorts of cutting-edge applications.
Wow. So this rare metal could be a key player in shaping the future of technology.
Absolutely. And, speaking of shaping the future, we were talking about ruthenium's role as a catalyst before the break.
Right. Those little helpers that speed up chemical reactions.
Exactly. And we touched on Grubbs catalyst, which was a huge breakthrough.
Yeah, the Nobel Prize winning one.
That's the one. It's used in this reaction called alkene metathesis.
Okay, I'm going to be honest. I still don't quite grasp what alkane metathesis actually does.
I don't blame you. It's a pretty complex reaction. But imagine you have a set of Lego bricks, right?
Okay, I'm with you.
Each brick is like a molecule.
Got it.
Alkene metathesis, with the help of that ruthenium catalyst, is like having a special tool that lets you detach and reattach those Lego bricks in any combination you can think of.
Oh, okay. So it's like molecular Lego.
Precisely. It lets scientists build new molecules with incredible precision.
So ruthenium is like a master builder at the molecular level, helping to create all sorts of new material.
That's a great way to put it. And this ability to manipulate molecules on such a fine scale, it opens up a world of possibilities for new medicines, high-performance polymers, all sorts of things.
Wow. So ruthenium is not just about durability. It's also about precision and creation at the tiniest level.
Exactly. It's involved in both building and breaking things apart in the most amazing ways.
Okay, I'm trying to keep up here. So we've talked about electronics, catalysts. Oh, and I remember you mentioned something about ruthenium being used to reveal fingerprints at crime scenes.
Oh, right. Yeah. That's another one of its surprising uses.
It's like a high-tech dusting powder.
Kind of. It's ruthenium tetroxide that's used, and it reacts with the oils and fats in fingerprints, making them visible.
Wow, so ruthenium's helping to solve crimes now, too.
In a way, yeah. It's a really valuable tool for forensic scientists.
Okay, so from the heart of our electronics to the scene of a crime, ruthenium really is everywhere. And speaking of everywhere, our sources also mention some really promising medical applications, especially in the fight against cancer.
That's right, and that's one of the most exciting areas of research right now.
Yeah, I was reading about that. So how are they using ruthenium to fight cancer?
Well, they're developing ruthenium-based drugs that seem to behave differently in the body compared to some other metal-based drugs, like the ones that use platinum.
What's different about them?
For one thing, they seem to be more resistant to breaking down, and there's also some evidence suggesting that they can target tumor cells more precisely while leaving healthy cells alone.
Oh, wow. So it's like a stealthy warrior sneaking in and taking out the bad guys.
That's a great analogy. Of course, it's still early days, and there's so much more to learn.
But it's pretty incredible to think that something so rare could potentially have such a huge impact on human health.
I know, right? But that brings up an important point. Ruthenium is incredibly rare.
Right, we talked about that. So how does that affect its use in all these different applications?
Well, it definitely limits how widely it can be used, especially for large-scale industrial processes. It's more of a specialized material reserved for those applications where its unique properties are really essential.
So it's a precious resource, something to be used carefully.
Exactly. And that's part of what makes it so fascinating. We have this element born in the heart of stars, existing in almost undetectable amounts, and yet it's having such a profound impact on our world.
I know, it's really mind-blowing. From the electronics in our pockets to the frontiers of medical research, ruthenium really does connect us to something much bigger than ourselves.
It does. It's a testament to the ingenuity of humans and the interconnectedness of everything around us.
Well said. Okay, we've journeyed from the depths of the Earth to the forefront of medical research, exploring ruthenium's history, its quirks, and its incredible uses. But there's one more fascinating aspect of ruthenium that we need to talk about, its connection to the world of nuclear science. All right, we're back and ready to tackle the last part of our ruthenium journey, nuclear science.
That's right, the nuclear frontier.
I'll be honest, whenever someone says nuclear, my mind kind of jumps to power plants and weapons.
Yeah, those are the big ones, for sure.
It can be a bit intimidating to think about, you know.
Oh, I get it. But nuclear science is also a window into the fundamental building blocks of our universe.
The elements.
The elements, exactly. And ruthenium has a really unique story to tell in this realm.
Right, we talked about the Oklo natural nuclear reactor.
Ah, yes, nature's own nuclear reactor.
Finding ruthenium there is like finding a message in a bottle from billions of years ago.
It tells us so much about those ancient nuclear processes. And it shows us that ruthenium, or at least some of its isotopes, can really stand the test of time.
So it's a survivor. But you mentioned that ruthenium might also play a role in the future of nuclear science, right?
Right, and that's where things get really interesting. One of the biggest challenges with nuclear power is dealing with the radioactive waste.
Yeah, that's a big one.
Right, it's got all sorts of radioactive elements in it, some that can stick around for a really long time.
Thousands of years, even millions, right?
Yeah, it's a serious concern. But here's the thing, ruthenium is present in that waste. And some of those radioactive ruthenium isotopes, well, they can be separated out.
Wait, so we can actually pull ruthenium out of nuclear waste?
Yep, and potentially even use it for beneficial purposes.
So it's like nuclear recycling, turning something hazardous into something valuable.
Exactly. Some researchers are looking into using these extracted ruthenium isotopes for medical treatments like radiotherapy, and others are exploring industrial applications like making super sensitive detectors.
Wow, that's amazing. It completely changes how we think about nuclear waste.
Right. It's not just something to be buried and forgotten. It could be a source of valuable materials.
Okay, I have to ask, how do they actually get the ruthenium out of the waste?
It's a pretty complex process involving a lot of sophisticated chemistry.
I bet. And I'm guessing there are a lot of safety precautions involved, too, since we're talking about radioactive materials.
Oh, absolutely. Safety is paramount when it comes to anything nuclear.
Of course. But it's still a fascinating idea. Taking something that's seen as a problem and turning it into a potential solution. That's what I love about science, you know.
Me too. There's always something new to discover, some new way to look at things.
Well, I think that's a perfect note to end on. We've gone from the heart of ancient stars to the cutting edge of nuclear science, exploring ruthenium's history, its properties, its uses. It's been quite a journey.
It has. And, for such a rare element, ruthenium has had a pretty big impact on our world.
It really has. And who knows what the future holds for this remarkable element. Maybe someday it'll be powering our spaceships or curing diseases. The possibilities are endless.
Well, on that note, thanks for joining us for this deep dive into the world of ruthenium. We hope you learned something new and maybe even discovered a newfound appreciation for this tiny but mighty element.
And until next time, keep exploring and stay curious.